So architectural best practices for reliability. So building a reliable application in the cloud is different from traditional application development. While historically you may have purchased levels of redundant higher-end hardware to minimize the chance of an entire application failing. In the cloud, we acknowledge upfront the failures will happen. Instead of trying to prevent failures altogether, the goal is to minimize the effects of a single failing component. Reliable applications are resilient and highly available. So in this section, we want to describe about 6 steps for building reliable Azure applications. So define requirements, develop availability and recovery requirements based on the decomposed workload and business needs. Use architectural best practices, follow proven practices, identify possible failure points in the architecture, and determine how the application will respond to failure. Test with simulations and force failovers. So simulate faults, trigger force failover, and test detection and recovery from these failures. Deploy the application consistently. Release to production using reliable and repeatable process. Detect failures, monitor indicators of potential failures, and gauge the health of your application. Identify when a failure occurs and determine how to address it based on the established strategies. So requirements. So we the first thing is define requirements. So we will go through each of the 6 best practices that we discussed. And first one was define requirements. So identify your business needs and build your reliability plan to address them. So we need to consider the following points that you see on the screen right now. So identify workloads and usage. A workload is a distinct capability or task that is logically separated from other tasks in terms of a business logic and data storage requirements. Each workload has different requirements for availability, scalability, data consistency, and disaster recovery. So first thing you have to do is identify your workloads and see what is the availability, what is the scalability, how you are planning the disaster recovery for that. Plan for usage patterns. So usage pattern also play a role in the requirements. Identify the differences in requirements during critical and non-critical period. For example, a tax filing application can't fail during a filing deadline. To ensure uptime, plan redundancy across several regions in case one fails. Conversely, to minimize the cost during non-critical period, you can run your application in a single region. Establish availability metrics, mean time to recovery and mean time between failures. So MTTR is the average time it takes to restore a component after failure, and MTBF is how long a component can reasonably expect to last between outages. So use these measures to determine where to add redundancy and to determine service level agreements for customers. Establish recovery metrics, which includes the RPO and RTO. So RTO is the maximum acceptable time an application can be unavailable after an incident. RPO is the maximum duration of data loss that is acceptable during a disaster. So derive these values, conduct a risk assessment, and make sure understand the cost and risk of downtime or data loss in your organization. Determine the workload availability targets. So to ensure that the application architecture meets your business requirements, define target SLAs for each workload. Account for the cost and complexity of meeting availability requirements in addition to application dependencies. Understand service level agreements. In Azure, SLA describes Microsoft commitments for uptime and connectivity. If SLA for a particular service is 99.9%, you should expect the service to be available 99.9% of the time. So define your own SLA for each of the workload in your solution. You can determine whether the architecture meets the business requirement. For example, if a workload requires 99.99% uptime but depends on a service with 99.9% SLA, that service can't be a single point of failure in the system. Now let's see the architectural best practices. During the architectural phase, focus on implementing practices that meet your business requirements identify failure points and minimize scope of failures. So first of all, perform a failure mode analysis, also called FMA. FMA builds resiliency to your application early in the design stage itself. It helps you to identify the types of failures your application might experience, the potential effects of each, and possible recovery strategies. Create a redundancy plan. The level of redundancy required for each workload depends upon your business needs and factors into overall cost of your application. Let's say you need a zone redundant storage account, then you have to switch the redundancy to ZRS. Design for scalability. A cloud application must be able to scale to accommodate changes in the usage. So begin with the discrete components and design the application to respond automatically to large changes whenever possible. Keep scaling limits in mind during design so that you can expand easily in future. Plan for subscription and service requirement. You might need additional subscriptions to provision enough resources to meet your business requirements for storage, connections, throughput, and more. So keep that handy. Plan ahead for subscription and service requirements. Use load balancing to distribute the request. So in 303, we have seen how application gateway and load balancer can be used to create a highly available solution. So load balancing distributes your application's request to healthy service instances by removing unhealthy instances from rotation. Implement resiliency strategies. So resiliency is the ability of a system to recover from failures and continue to function. So implement resiliency design patterns such as isolating critical resources, using compensating transactions, and performing asynchronous operation wherever possible. Build availability requirements into your design. So availability is a proportion of time your system is functioning and working. Take steps to ensure that the application availability conforms to the service level agreement. For example, to avoid a single point of failure, decompose workloads by service level objective and throttle high volume users. Manage your data. So how to store, backup, and replicate your data is critical. So choose a replication method for your application data. Document and test failover and failback processes. Protect your data and plan for data recovery.
So guys, this was our expert, and if you want to dive deeper, then we have something really special for you. We have our free class on how to prepare for Azure Cloud jobs and certification. Under this free class, you'll be learning about why you should learn Azure Cloud certification roadmap for cloud engineers and architects, and many questions that you might be wondering about. All you have to do is just log on to K21Academy.com/AZ-30502. You'll be seeing this kind of interface. Just click on book your free seat now. Schedule an event date according to your availability. Add your full name, your email address, your phone number, and click on yes, save my seat. After that, you'll be seeing this kind of link on the extreme right. Add this link to your calendars, and I'll see you in the free class. Till then, take care and keep learning.